Keoni here from the Hunting You podcast. It is absolutely frigid today, and so I am inside working on some props. And I want to talk about a new product or a new way of using a product that I have been experimenting with for the last couple of weeks. This is the door lock actuator for a car. You know, when you push the button and it makes your doors lock or unlock? This is what does it. And this is a super simple 12-volt actuator that can be used for really any kind of linear motion prop, as long as you have a very short throw. It moves quick, but has a very short amount of distance that it can operate. But I have discovered there are some intricacies to using this actuator, so let's get into it. The wiring of these actuators is super simple. You have just two wires. And so when you apply voltage one direction, it will make the actuator go out. When we apply it reversed, it makes it go in. But the way this thing works, you have a 12-volt motor inside the casing, and there's a small gearbox along here. So when the motor turns on, that's what causes it to move. But if there's a voltage applied, it will continue, or it will just stay there. And so it created a problem the first time I tried to wire one of these up. This is a Fright Props peekaboo controller. The way the peekaboo works, you have a couple of relays that just act as simple switches. So the peekaboo has two, output 1 and output number 2. 3 terminals each with a normally closed, a normally open, and a common contact in the middle. So in order to get any kind of power to these relays, you have to jumper the power from your power terminal over here, this is the red wire, to where you want the power to go. So the way I would normally wire a linear actuator, I take a positive from the positive terminal all the way to the normally closed. The common on the normally closed would then go out to my linear actuator so that it is normally receiving 12 volts. And then the negative from my linear actuator comes back to what would be the negative. And in this case, I put the negative on the opposite channel into the common, with the normally closed going back to the negative. That way, when relay number 1 is closed, we have 12 volts go into the actuator. It will come out. And then when relay 2 closes, it will reverse that voltage and cause the linear actuator to come back in. But the way the peekaboo works is on the normally closed terminal, that voltage is always there. It is always 12 volts. And because this is just a simple 12-volt motor inside, that means it is constantly receiving 12 volts. And the first time I tried it with this particular actuator and this peekaboo controller, I burned up the motor. I fried it. So I had to go to a different way of wiring this actuator. This controller is the Ammon Quadro from Purgatory Props, and it's a little bit different than the controllers that we get from Fright Props. Fright Props peekaboos are simple relays. There is no voltage there unless you wire it that way. The Ammon series, on the other hand, gives you 12 volts at the terminal. And so I have 12 volts across each one of these 4 terminals anytime that relay is closed. So watch what happens when I close the relay here on number 1. I'm going to record just a simple program to demonstrate what this does. So to record on the Ammon Quadro, you push the play record button until it turns red.
Help! Help! Let me out of here! I'm stuck! Who locked me in? Why is it so dark? I can't take it much more!
Notice how every time I pushed the relay, the actuator moved out. And then when I took my fingers off the relay, the voltage went away and it collapsed back. That's exactly the motion that I want for the prop that I'm using, because I'm going to be using this just to shake some chains that are hanging on a coffin. Keep in mind, though, that anytime that relay is closed, this motor is receiving voltage and it is locked. And so if you hold it out there, hold the relay closed so that it's extended, then you're going to be constantly feeding voltage, constantly feeding current to that motor, and you're going to burn it up. Another thing I noticed with this particular actuator, you have to have enough current to drive it as well as power the controller. So I was using a 5 amp power supply to control this. Watch what happens when I switch to a 2 amp power supply. So you see, plugs in just like normal, but watch what happens when I try to play the animation.
Help! Help!
The moment this tried to turn on, it drew more current than the controller could handle, and it shut itself off.
Help! Help!
Immediately. So if that ever happens to you, that's a sign that you need to put a higher amperage power supply onto your controller. Back to the peekaboo for a moment. I want to show you what happens very similarly when I don't have enough current supplying to this peekaboo. Watch how the controller reacts. It keeps trying to start up. That's where we see the lights coming on. It tries to supply 12 volts to the actuator, but it's drawing more current than the actuator and the peekaboo can handle, and so it is turning immediately off. So if you ever see your peekaboo twitching like this, that's a sign that your power supply needs a higher amp rating. That is how I'm using these car lock actuators to make some chains move back and forth. Super simple, super cheap. I found these two on Amazon for $6.59 for 2 of them. That's $3.30 a piece. Like, incredibly cheap, but a super easy way to add some motion to your display. I will post a link to these actuators into the notes of this video. If you'd like to learn more about the Haunting You podcast, definitely go check us out at hauntingyou.com, just the letter U, and make sure you like and subscribe this video so that you can be notified every time that we post a new video. In the meantime, feel free to drop any questions in the comments, and we'll see you next time. Happy haunting!